right, we'll see you later, Jaden.
Bye.
Are you playing, huh? What are you playing? What kind of pablum are you playing?
A game.
Of course you're playing a game. What game?
Marvel Future Fight.
Marvel Future Fight. I see. I see. Is your stable of fighters then?
I just use characters.
It's afternoon.
Yes, it is.
Good afternoon.
Good afternoon.
Good morning.
Them games are sucking your brains out your ear.
Yeah.
It's like putting
How are you doing well in that?
putting a straw in your ear. That's what it's like. Your intellect must be considerable because despite being stuck on those games for the better part of the year, you're still quite an intelligent young man.
I still do my homework.
What's that?
I still do my homework.
Like I said, you're an intelligent young man.
Play games and they don't do.
Yes, I concur. I relate to that so much. And when we do our homework, good things happen, don't they, Tyson?
Yes, yes,
Yes.
Oh, I have my internet.
Speaking of which, I think I'm going to hand something out to everybody. Yeah, I didn't do it this morning, though. I was delinquent in my duties this morning. But I got it now, so might as well do it now. And Alex, you are the first one I bear good news to. And then I got Kaylee is here. I bear Kaylee good news. Caleb is not here. Liv is not here. She was here this morning. Let's see, I forgot to do this morning. Sam was here this morning. Kai was here this morning. No, he's here this afternoon, I think. Kane, is Kane coming today?
No.
He's in the morning class.
Yeah, he's not here.
Zach is in the morning. Riley is in the morning. Morgan was in the morning. Dawson was in the morning. See what I did here? Logan Nelson, I think he's going to be here later this afternoon. Noah was here this morning. Wheel will be, he's not going to be here either because, well, wait. You don't have baseball today?
No.
Okay. Kian was here this morning.
Will was supposed to be here this morning, but he had a...
Abby is not here yet. Hannah's here. Let me get to you because I'm standing right here, so I might as well. This is really what reminded me to do that. Hannah, keeping it 100, Tyson.
What's that?
Keeping it 100. I think Callie is the most patient person in class because her last name begins with a Z. Yes, you may. All right. Where are we at? Are we already? Is this my class today?
Yeah,
Yeah.
I don't know.
It's AP test day, isn't it? That's what it is. It's AP test day. So it's very important that I get this out.
No, once your Wednesday's home, that's your Wednesday's out.
Are they?
Yeah.
Are they? Let's see. Hey, there you are.
Blame Logan.
So AJ's not here. Logan's here. Josh is not here. Alex and Kaylee's here. Logan's not here. Hannah's here. Kristen's here. Tyson's here. Hallie's here. All right.
No,
All right. In that case, here you go. Here you go. All right. So let me start recording. All right, we're recording. So, yesterday we got done with a few things. One, we covered the dividing out technique, yes? We also covered the rationalizing technique. This one, approximating limits of functions graphically and numerically. We covered that in section 1, so that's done. Okay? The next one is evaluate one-sided limits of functions. We are going to do this. And I know some of you are excited about that, and some of you are disappointed about that. Logan, put the phone away.
Logan's disappointed.
No, I had nothing to do with that. Put the phone away.
He's disappointed that you're not doing that.
Now, I will cover it real quick, but it's not something that we're going to be testing on. Sometimes I look at limits from only one side of a variable. So as x approaches 2, from the positive side of the number line, meaning I'm coming from over here and I'm drilling down to x equals 2 going this way, I look at that limit. And then I can do it from the other side, right? I can do as x approaches 2 from the negative side of the number line. So I'm over here and I'm drilling towards x equals 2 and seeing what my function does going this way towards x equals 2, okay? That's all one-sided limits are, okay? They do come into use on occasion, but not often. Not often. And it really doesn't help us further our understanding of limits or calculus going forward. So we're going to jump it. You're going to cover it more in depth next year in calc if you choose to go that route. But we are definitely doing the evaluating limits of difference quotients from calculus. Matter of fact, we're going to do that right now. So bust out your notebooks, note paper, and we are going to analyze this function. And we're going to analyze the limit as h approaches 0 of the difference quotient. Okay? Now I tried to connect to this what we're actually doing here. I don't think I'm going to do that in this class. I think I'm just going to tease it, and then we're going to reveal. We're going to do the big reveal in the next lesson when we talk about tangents. Okay? So for now, I just want to do the difference quotient and analyze that limit as h approaches 0. So the first question I ask is, can I do direct substitution right now for this limit? Why not, Logan? What happens when I plug in 0 for h? Yeah, it breaks my function because I put 0 in my denominator. Okay? So, bad, right? So I need to come up with a different strategy here. Okay, so one thing I'm going to do is I'm going to analyze f of 3 plus h. How would I do that? I'm going to write this in red. What is f of 3 plus h? F tells me to do what? It takes x and does what?
Plug it in.
What does it tell me to do to x? It tells me to square it and then subtract 1. Except here I'm not doing that to x. I'm doing it to what? 3 plus h. Right? Whatever's in the parentheses, that's what I replace x with in the formula or in the function. So this is going to be 3 plus h squared, like this, minus 1. So here's what I'd like you guys to do. I would like everybody to evaluate f of 3 plus h. Quiz yesterday. You weren't here for it. Okay, so I need to make up time from you, okay? Who else came in? Logan and Josh came in. While you guys are doing that, I'm going to hand a couple quizzes back. Logan. Yeah, I apologize. Josh.
Thank you, Mr. President.
Thank you. And Logan. You're hard to find because you're in the middle of the alphabet. Josh here's easy to find because he's at the beginning of the alphabet. You're really close, okay?
On what? The top one?
The top one you got,
Oh,
okay?
The
On the back one, you kind of made a little...
Yeah, I remember. I was supposed to put
Right.
the 6 in front of the limit.
Yeah.
I looked at my notes after and I was like, shoot.
This one,
Yeah,
you just...
I made the domain in the range.
What's that? No, we
Or
just
what did
need
it-
to... We just need to...
That one either.
Well, we did
I
it.
have
We
no
did
idea
it.
what that was asking for.
We'll do it. We'll do it again. We'll do it again when we go over some of the problem set stuff. Okay. All right. So let's see what you get, Kaylee. Nice. Nice. What'd you girls get? What did you get? Let's see what you got.
I don't really.
What do you do first?
Do you want me to factor?
Pem, well, no, I want you to evaluate this.
Oh, so then you would go.
Can I distribute a power? No, I can distribute a factor, but I can't distribute a power. How do I do squared? How do I do a binomial squared? All right. So, what did we get for f of 3 plus h, Tyson? What'd you get?
Well, first I got h squared plus 6h plus 9,
And then,
and then minus 1.
yeah. So what was the final answer?
H squared plus 6h plus 8.
Plus 8. Okay. Now, back to our limit of the difference quotient. What do I replace with this red polynomial? This guy, right? That's what I replace with this guy. So let's rewrite that. I'm going to color code it too for our benefit. So it's the limit as h approaches 0 of h squared plus 6h plus 8. Okay? And I'm going to stop right there for the time being because now I want to evaluate this f of 3. So what do I do to evaluate f of 3? What do I put in for x? 3. And then you just plug and chug, right? So 3 squared
9.
minus 1, 8. So then what do I write after this plus 8? Minus 8. And then that's all over h. I said I was going to color code this and I didn't. I apologize. But it's too late now.
Then you can cancel.
Yeah, the 8s go away, right, Logan? Because I take something, I add 8, and then I take 8 away, I'm just back where I started, right? So, then I am at this step. The limit as h approaches 0 of h squared plus 6h over h. So far, so good, right? Can I do direct substitution now? Why not?
So we get 0 out of the denominator.
Oh, yeah, I still got the same problem as I had before, right?
H plus 6. Factor.
Yeah, I can factor and cancel out. Or I could divide. Yeah, same thing, right? So, this equals the limit as h approaches 0 of, let's do the factoring way, right? So that we can see more clearly. This factored is h times the quantity h plus 6, right? Over h. And I'm doing this way because I want to point out something else. do you notice how I'm always writing my limit language? Every step I write that. Why do I write that? It does matter. Why does it matter? Riddle me this, Batman. If I had just... So I'm saying that the limit of this guy is the same as the limit of this guy. Right? Now, well, it is. They're the same function, right? But let me ask you this. If I just had... Oh, gosh. Why does that do that? If I had just this, and I left out the limit language, is that a true statement? Is the limit of this guy equal to that guy? No. Do you see why I need to keep the limit language in there? So that's one purpose. The other purpose, kind of more of a tactical purpose, is just to remember what the heck it is I'm doing, right? I'm evaluating this limit. So I keep the language of the limit in there. Okay? When do I take it out? We'll get to that point. Okay? We'll get to that point. But what do I do here? What can I do now?
Take out the x's.
I can cancel out common factors in the numerator and denominator, right? So now I got the limit as h approaches 0 of h plus 6, right? Now what? Now I can do direct substitution, right? Now I can say 0 plus 6. Because the limit of this guy as h approaches 0 is just 0 plus 6, right? That is a true statement, isn't it? So you see where I keep the limit notation and where I discard it? I'll be watching for that on the quiz. Okay? So this then equals 6. Okay? Okay. I don't know if you realize this or not, but we just did calculus. We just did calculus. Okay? Now, we got the problem set, or the practice set here. I figure for demonstration's sake, I can do problem 1, problem 3, and problem 19 with you guys in class today, just to give you some inspiration and some motivation towards how to do the problems in the practice set. Would we like that?
Yes.
I got one yes. Yes?
Yes. If you weren't to do that, would you give us work time on the problem set?
Yes. And you can choose to use that work time on the problem set and not on some other activity. But who else? If it's just Tyson, I'll just go over and hang with Tyson. Logan would like that too? Definitely Logan and Josh, because we're going to cover that here in a hot second. Okay, so number 1. Let's do number 1. Now the instructions for number 1. It says in number 1, for number 1 through 4, I think it is, to find the limit of this function graphically. So for letters A, B, and C, I need to find the limit graphically. Okay? So this is exactly that question 2 on your quiz, right? And then it also asks me to find another function. So this is the function, and this is the graph of the function. They tell me to find another function that looks a lot just like this, except for it's different at one point. Okay? So we're going to do both of those things together for number 1. Hopefully that helps you with 2 and 4. Okay? So let's do that. Let's look at the graph of g of x. And think about what is the limit of g of x as x approaches 0. What do I do? If I'm doing this graphically, I get on my horse, get on the graph trail, right? And I am starting over here and going towards x equals 0 along the function, right? And I go along and along and along, And what happens as I get close to x equals 0, what value does the function get close to as I get towards x equals 0? If you look at the graph, it says 1, right? And if you don't like the resolution of this, look in your book on page 798. And it'll be a little bit better resolution for you. But it goes towards y equals 1, right? Now what do I have to do? Am I done with this? Can I write 1 here? What do I need to do still, Logan Nelson? Go the other way, right? I need to hop on my car over here, on my horse over here, and do the same thing going down towards x equals 0. And as I get closer and closer to x equals 0, what does y get closer and closer to? 1. It gets closer to the same number going each way, right? So now what can I do? Am I done? I can declare this limit equal to 1. Okay? Hi, Miss Pollock. What's up?
I just need this one. It's ASAP.
Is that a Garrett thing?
Yeah.
Okay.
Thank you.
Yeah. All right, so we're done with this one. Now, it asks me to evaluate the limit of the same function, but this time as x approaches -1. So let's get rid of this, and get rid of that, and get rid of that. I don't know why that's up there, and get rid of this. Why is that there? I don't know. All right, so, again, I'm going to hop on my horse, right? I'm going to start this way and go towards x equals what? -1, right? And as I get closer and closer to x equals -1, what point am I getting closer and closer to on the y-axis? 3? I think it's 3. If you look on your book, it's going to give you a better picture, and I think it's 3. Okay? Now, I hit my thing on the other side, right? I hit the trail on the other side and go towards and towards and towards, and uh-oh. I got a problem here, don't I? What's the problem? There's a hole in the road. So my question is, do I start here? Or do I start here? Yeah, because I don't care about the hole, really. I care about the immediate neighborhood around x equals -1, right? So as I get closer to -1, what's my function getting close to? 3. Same number as this way, right? Because they're the same number, I can declare that 3. What do you think my reasoning or my process is for letter C? The limit as x approaches -2. Does it change? My process is exactly the same, right? I hop on my horse, and this time I go down until x equals -2, which is right about there. And what does y equal when x equals -2? Don't look on my thing. Look on the book. The book's much better. You got to rely on my artwork here, and that's a bad idea. 5, yeah, 5. Where do I hop on the trail going the other way?
1.
Yeah, just on the other side of 1, right? Or just on this side of -1. And go, or not -1, +1. 0, 1, right? Yeah. And go this way. And what number do I get close to as x approaches -2?
5.
Same number, right? So we've done A, B, and C. Now the ersatz letter D asks us to find a function that looks just like this, except differing at one point. And we just did this. How did I go about finding another function that looks just like this one in the last problem, which was my difference quotient, right? How did I do that? I pulled out well, here it wasn't an x, it was an h, right? But here it's going to be an x. I can factor out an x from the numerator, right? I get x times negative 2x plus 1. And then that's over x, right? X's cancel, and I get, shall I call this h? H of x equals negative 2x plus 1. Now it says, find a function that agrees with the original function at all but one point. Does h of x meet that criteria? What point does it not agree at? 0, 1, right? The whole. It doesn't agree at the whole. Because there is no hole in h, is there? Okay. Number 1 gives you motivation for number 2 and number 4 in the practice set. Now we're going to jump to number 5. And number 5 gives us very specific directions. It says, find the limit if it exists. Use a graphing utility to verify your result graphically. Use a graphing utility to verify your result graphically. That sounds like directions from the Department of Redundancy Department, doesn't it? All right. So I'm evaluating the limit as x approaches 6 of this function. Let's try direct substitution first. What happens when I put 6 in for x? I get 6 minus 6 is 0 in the numerator, right? In the denominator, I get 6 squared, which is
36.
Minus 6,
37. Minus 30.
or minus 36
0.
is 0. Can I do that? No, so I need to have another strategery, right? What strategery would we do? We could do numerical. We could do graphical, right? But I can't do graphical because they want me to use that later to verify, right? So what do we call that method? I factor first and then I divide out. Divide out. Okay? Okay, so let's do that. Let's do that. So, can I factor the numerator? Some dissension in the ranks. Can I factor the numerator? I can factor a 1 out of the numerator, right? Yeah. I can factor a 2 out of the numerator. 2 times the quantity, 1/2 x minus 3. I can factor a 2 out of there, right? 2 times 1/2 x gets me x. 2 times negative 3 gets me negative 6. What's the point, though, right? Yeah, there is no point. There is no point. It's a very good point, Josh. I have no point often. All right, so I can't factor the numerator. Can I factor the denominator?
Yes.
All right. Josh is like, get on with it. So the limit as x approaches 6 of, everybody, factor the denominator in your notes. What do you get? Look at Tyson's on it, like white on rice. Yes, sir. Yes, sir. Yes, sir. Look at that. You're on candid camera. Look at that. Nice. Way to keep the limit notation in there. We're still analyzing the limit, so I see everybody's writing their limits in there, not skipping that step, keeping track of where they're at. And I see a lot of this. Oops. That's what I meant. That's what I meant. Okay. So, we do that. Now what can I do? I can cancel out like factors in the numerator and denominator, right? This one goes away with that one. And what am I left with in the numerator? A 1. Okay, so now I got keeping my limit notation, I got the limit as x approaches 6 of 1 divided by x plus 6. Can I do direct substitution now? Well, let's find out. Tyson says yes. X, let's substitute 6 in for x. 6 plus 6 gets me 12. Oh, goody. I can do that. So 1 over 12. Do I need the limit notation anymore? No, because this is what the limit equals, right? I don't need to say the limit of 1/12. I don't need to say the limit as x approaches 6 of 1/12. That's like more Department of Redundancy department stuff, right? Okay. So there's your answer. Now, graphing utility, right? Use a graphing utility to verify. So we get to play with Desmos. We get to play with Desmos. We didn't do this in the first class. I forgot to do this. So f of x equals x minus 6. Oops, I forgot to put my parens. Divided by x squared minus 36. And look at that. Look at that. That don't look right, does it? Look at that. What is going on there? Doesn't have an approachable thing, does it? Let's try this. Let's try g of x. Equals, and we'll do parens, x minus 6 divided by x plus 6 times x minus 6. And I get the same thing, right? Now let's do h of x. Equals 1 divided by what? X plus 6, right? Now, here's the trick, right? Where am I going wrong? Am I concerned about this point right here? Am I concerned about that region of my graph right there? Not at all. What point am I? My eye immediately went there, though, didn't it? Just like y'all's did, right? But is that where I want to look? Where do I want to look? I want to look where? I want to look at where x approaches positive 6, right? I want to look at f of positive 6. So if I go back there, I want to get rid of this business, right? I want to look at f of 6 right there. So here's what I'm going to do. I'm going to get rid of that one. I'm going to get rid of that one. And I want to look at, what is that value right there? Look at that. It's 0.077, right? 0.079, 0.08, 0.082, 0.083. If you do 1 over 12, what do you get? 0.083 repeating. When x equals 6, though, baby, a hole there, right? You see that? But where is it on either side of 6? 0.083, which is 1/12. Okay? So don't let this part of the function fool you. We're looking at that part of the function. Okay? God, I love that. All right. Last one, number 19. This hot mess. What's our first step? Let's try direct substitution, see what happens. I put -3 in. Let's just skip to the denominator because that's usually where we have our problems, right? -3 plus 3, 0. Oh my, look at that. We got a problem. What strategy am I going to look at to resolve this one? Rationalizing. Rationalizing. What's the goal of rationalizing? I don't want a radical up here. I don't want a radical in the numerator this time. My hope, and it is a hope, is that I might be able to cancel some stuff out if I rationalize. Okay, so let's rationalize and see if that works. So I'm going to look at the limit as x approaches -3 of square root of x plus 7 all minus 2 over x plus 3. And what am I going to multiply numerator and denominator by in order to rationalize the numerator? What gets rid of my radical? The square root of x minus 7, right? But if I just do square root of x minus 7, right? I do square root of x minus 7 times square root of x minus 7. That's x minus 7. Radical's gone, right? But I got to distribute, right? Minus 2 root x minus 7. I got to do something else. What do I have to do? Who remembers the trick? Hallie. Not quite. Not quite. Not quite. Not quite. Not quite. Close. Close. I'm basically going. Ooh, I'm sorry. That's supposed to be a plus, isn't it? Plus 2. It's the difference of squares trick. We should give that a brand name because we use it a lot. It's the difference of squares trick. I'm going to brand that stuff. I'm going to copyright it. I'm going to charge everybody a nickel every time they say it. It's going to catch. I don't care about you. You're one guy. So in your lifetime, you might give me 15 cents. I'm looking at everybody. So they post on YouTube. They call it the difference of squares trick. Bing, I get a cent. Or I get 5 cents. I'd be rich. I'd be rich. What should I do on the denominator? Same thing, right? Are we out of time? When you multiply the numerator, you get limit x approaches -3 of. Oh. God, why does it do that to me? Of x plus 7 minus 4. Square of the first term, square of the second term, minus in between. How does that simplify? X plus 3. I'm going to get rid of all this business and just replace it with a 3. Because the bottom has x plus 3 times square root of x plus 7 plus 2. And now I can cancel out factors in the top and bottom. Can I do direct substitution now? -3 plus 7.
4.
4. Square root of 4.
2.
2. Plus 2. 4. I can do that, right? This equals 1/4. And I don't have time to look it up on Desmos. I'm sure you will do so and enjoy your day. Again, this problem set is going to be spent doing workday tomorrow, due on Friday. Thank you for your time, ladies and gentlemen.